Over here, we are going to discuss about working of DHCP. This is the same lab in which we have performed inter-VLAN routing and also we have performed the VLAN trunking protocol lab. If you remember, we have configured DHCP, but I told you that we will be learning about the working of the DHCP, and that is what we are going to learn over here. And then thereafter, we will perform a small lab as well. So as we all know, DHCP stands for Dynamic Host Configuration Protocol, and DHCP, it works on the application layer of the UDP protocol. It works on the application layer. DHCP works on application layer of the UDP protocol. So as we all are aware that the main task of DHCP is to dynamically assign IP addresses to the client and allocate the information on the TCP IP configuration to the client. So the main task of DHCP is to assign IP addresses dynamically to the clients, assigning the IP addresses dynamically to the clients. Now, there are few things that need to be remembered. One is the DHCP port number. So when you talk about the DHCP, the machine which is requesting for the IP address, in our scenario over here, we will take one example. Let's take an example of this PC2. So this PC2 is a client, and from the source where it will get the IP address, in our case it will be the layer 3 switch, 3650 switch. The distribution switch over here will be the DHCP server. It will be acting as a DHCP server. Why? Because we have configured the DHCP over here, and this switch will be allocating the IP addresses dynamically using DHCP, Dynamic Host Configuration Protocol. So this will be termed as server. The one who assigned the IP address is the server, and whom the IP address is assigned dynamically is termed as client. So always remember that DHCP port number, the DHCP port number for server is 67 and DHCP port number for client is 68. This is something which you need to remember with respect to interview. The DHCP port number for server is 67 and the DHCP port number for client is 68. And as I told you, the DHCP works on UDP. And over here, whenever this specific machine, a client machine, in our case, we have taken example of this PC2. So let me just highlight that as well. This in our class over here, what we are going to do is we will be assuming this PC2 as our client machine, and this layer 3 switch is the place where we have configured DHCP. So this is going to be our DHCP server, and we are going to configure, we are going to do a lab again. Although we have already configured in our inter-VLAN routing, just I have shown you, but over here we are going to understand in depth how the DHCP actually works in the backend. So this is the DHCP server, the layer 3 switch, and this is going to be the PC. Remember, in DHCP, there are lots of message exchange. Mainly, there are 4 DHCP messages. Whenever the PC over here request for the IP address that is assigned dynamically by the server, there are 4 messages exchanged between them to make a connection. There are 4 messages exchanged to make a connection, and that four messages which are exchanged are called as DORA. The four messages is nothing but called as DORA process, and stands for DORA stands for discover, DHCP, discover message. Then the next one is offer message, DHCP offer message, request message, and the last one is acknowledge message. Although in total there are 8 DHCP messages in the process, but these four are the main messages that is required to make a connection, and it is nothing but called as DORA process. DORA stands for discover, offer, request, and acknowledge. Now let's understand one by one how the messages are exchanged and how this process is completed. The complete DHCP process is completed in order for the client machine to get an IP address dynamically from the server. So initially, as soon as, let's say for example, this PC2 is a client machine, as soon as you click on the DHCP, so it is requesting for IP addresses. So what exactly is the process that it got an IP address dynamically? Let's understand that. As soon as you say to the PC to get an IP address dynamically over a DHCP, what happens? The first message is generated from the client machine. The first message is generated in the communication process, and that message is generated from the client machine. And this message is communicated between this client machine and the server. So what is this message? This message generated by the client is trying to discover if there is any DHCP server or servers, if there is any one single DHCP server or a group of servers available, DHCP server available within the network. So the first message which is initiated by the client machine, this message is to discover whether there is any DHCP server present in the network or not. So what happens? The first message from the client machine is broadcasted to all the devices present in the network to find if any of the device is a DHCP server. So this message, when it is broadcasted, it will go to all the broadcast. The same broadcast domain, it will go to all the devices. This broadcast will go to all the devices, and it will try to discover if there is any DHCP server available within that broadcast domain, within that network. So how it happens? So when this specific discover message is initiated as a part of communication, so the frame which is formed is something like this. Frame contains what all things the frame contain, that I will write down over here. It contains destination MAC address, and remember this destination MAC address is nothing but a broadcast address. It is a broadcast address. Then within the same frame it has source MAC address, which is nothing but the MAC address of the PC2. In our case, in our example, it will be PC2 MAC address, which is nothing but a source MAC address. The MAC address of the client which is requesting, which is trying to discover the DHCP server. The frame also contains source IP address. Remember, now it has not learned any IP address. It doesn't have any IP address. So in the frame, the source IP address is going to be 0.0.0.0. Then it has destination IP address in the frame. Remember, it is trying to discover. It has not discovered yet. It doesn't even know whether there is any DHCP server in the network present or not. So the DHCP server, even the DHCP server will be the broadcast address 255.255.255.255. and one more field is added in the same frame, which is nothing but client ID. It is a unique identifier of the client machine. Okay, the port number, as you know, the client port number is 68. So this specific message is broadcasted to discover if there is any DHCP server available in the same network. As it reaches to all of them, definitely it will be rejected because it was not meant for because the DHCP server is not running in this switch, it is not running in this PC, not in this switch, not in this switch. So as soon as it reaches over here, it has a DHCP server, it is a DHCP server, right? So this specific server will respond to this host, will respond to the host the message. Okay, again it will create one more message, which is nothing but an offer message. And in this offer message, it will specify the unleased IP address. Unleased IP address means it has a group of IP addresses, right? It has a range of IP addresses. This DHCP server will be having a series of IP addresses from that which is not used, which is not assigned. That specific IP address, unleashed IP address, it is called unleashed IP address, and some other information will be offered. And again, this offer message is also broadcasted by the server, by the DHCP server. This offer message is broadcasted. And remember, if there is more than one DHCP server, now let's say for example, instead of this we were having one more DHCP server, this was one more DHCP server for example, then in that case, you know, more than one DHCP server present in the network, both of them will respond to the discover message, and it will respond. When it respond, it comes to client. So over here, the client will accept the offer which is received first. Now let's say for example, this is layer 3 switch, which is a DHCP server, and over here also we have one more DHCP server running. So what happened? The client has generated the discover message that reaches over here as well as over here. From whichever DHCP server the first offer is received to the client will be accepted. And over here, let's understand how the frame is generated over here from the DHCP server, which is nothing but an offer message. So in the frame, the first field is going to be the destination MAC address. Remember that over here the DHCP server is responding to the message, to the discover message which it has received from the client, and it is preparing the offer message over here. So over here in this offer message frame, the first field will be destination MAC address, and this will be the PC2 MAC address, PC2 MAC address, which it has learned from the discover message frame. The next field is going to be the source MAC address, and source MAC address is nothing but the DHCP server MAC address. The next field will be the source IP. Source IP is nothing but the DHCP server IP. The next field is going to be destination IP, and remember the destination IP is still going to be broadcast IP 255.255.255.255. Why? Because over here it is offering the IP address. It has not yet decided that this will be your IP address. Remember, over here it is offering the IP address to the client. Now it is the client responsibility either to accept and acknowledge or reject it. So that it will again be a broadcast over here, and apart from that it will add the offer IP address. It is going to add the offered IP address, and over here it means to say that the client, it is saying that this is the IP address which I have with me right now. So for example, we will take that 172.16.20 192.168.20.51. For example, this is nothing but offered IP address, and it is going to add the identifiers similar to the client ID. A unique server ID will be added over here, and the server identity over here is nothing but the DHCP server IP. It will be over here. DHCP server IP will be there. One important field which it will add is a lease length. Remember, it is a dynamic assignment. It is a dynamic IP address. So whatever is dynamic, I told you it will have a timer. So similarly, it will have a lease length, meaning that it will have a time, how much time this IP is going to be available with you, and the entry will be flushed out thereafter. So it has a lease timer. So being an administrator, you can define the lease length. Let's say, for example, it will be 72 hours, that this IP is leased to you for 72 hours. In the offer message itself, it will say that I have this IP address offered, and it is going to have a lease line of 72 hours, for example. And again, the client ID which it has received, it will add it in the frame. And over here, it will offer a message. It will send an offer message in response to the discover message. The DHCP server has prepared an offered message, and again, this is broadcasted. So once it is broadcasted, of course, seeing at the destination MAC address, everyone will reject, and except this PC will accept it, saying that the MAC address belongs to me, and this broadcast pack message, which is nothing but an offer message, is accepted by this PC. Now, when a client receives an offer message, it respond by broadcasting one new request, that is nothing but a DHCP request message. In response to the offer message which it has received, what PC2 does, in our example PC2, what a client machine does, it will broadcast a new message which is a DHCP request message. Okay. So what is this request message? Basically, over here, the client machine is trying to check that the offered IP from the DHCP server, does it exist with any of the client? It is requesting to all the hosts in the machine whether this IP is there, whether there is any kind of duplication, and if there is any kind of duplication, if there is no reply, see, if there is no reply from any of the hosts, then there is no host with the same IP, and what will happen? The IP address will be accepted. In return, it will be accepted. Now over here, how the DHCP request message is sent, let's see that. So when the PC or a PC2 in our case, or a client machine, is trying to prepare a DHCP request, what it does is prepare a DHCP request using destination MAC address, and again the destination MAC address is going to be the broadcast address. It adds the source IP in the frame. Source IP address again is going to be 0.0.0.0 because it has not yet accepted the offered IP. It is trying to request to all the hosts within the network whether this IP is available or this IP is not available, meaning that there is no duplication, so I can accept it. The destination IP, the destination MAC is there, source IP is there, destination IP address will be there. Destination IP address over here is again going to be the broadcast IP 255.255.255.255. Source MAC is going to be the PC2 MAC in our case, and then the server identifier will be added over here. Server identifier will be added over here, which was known to PC2 using the offer message. When the offer message was sent, at that time the server ID came, right? So the same server ID will be added in the frame, and the server ID will be nothing but the IP address of the DHCP server. Along with that, it will add the request IP address, the offered IP address, this one, the offered IP address from the server is added over here in the field as the request IP address. And in our example, it is 172.16.20.51 offered by the DHCP server. And apart from that, the client ID is added in the field. And over here, this specific client is broadcasting and requesting if there is any such IP address available within the network to avoid any conflict. Now, if there is no reply to this request message from anywhere, then you know what this client do? This client, the PC2 in our example, will send a host. This client host will send a broadcast DHCP request message, the same DHCP request message to the server showing the acceptance. It will tell the server, see the same request message which was sent to all but no reply was received will also be sent to the server showing the acceptance that yes, this IP is accepted by me. The IP address which you have offered 172.16.20.51 is accepted by me. And finally, in response to the request message received from the client machine, the server will make an entry. And over here in the DHCP server, it will bind the client ID and the IP address. What it will do, this client ID, which was being initiated by the client machine, and it was always there in the frame as a part of the frame. This client ID will be mapped to the offered ID. The DHCP server has offered one IP address, right? Unleased IP address that will be mapped in the entry. And finally, the DHCP server will send an acknowledge message. And how this acknowledge message is, it is something like you will have the destination MAC, which is nothing but a PC2 MAC in our example, PC2 MAC address, or you can say the client MAC address which has initially generated the discover message. Then what else will be there? Source MAC address is going to be there. Source MAC address will be there. Then thereafter, source IP address will be there. So when you talk about source MAC address, it is nothing but the MAC address of your DHCP server. Source IP is nothing but your DHCP server IP address. Then what else will be there? Destination IP address is going to be there in the frame. This field also will be added. Destination IP address over here again will be broadcasted. Remember, this the complete process is a broadcast process. Huh? It is a broadcast message is being sent. The complete DORA process is a broadcast message. So it will be 255.255.255.255 and the IP address over here will also be there. The offered IP address will be there. In our case, we have taken example of 20.51, 172.16.20.51. This IP address will be there. Then the identifier, server identifier will be there, which is nothing but the IP address of the server itself. Then apart from that, you will have lease length, the lease timer of the IP address will be added as one of the field in the frame. And then the client identifier will be one of the field available. Client identifier will be there, and this is where your DORA process is completed, and the IP the client over here, which is PC2 in our example, will get the IP address using the DORA process. Apart from that, the four main messages, there are four more messages. That is DHCP negative acknowledgement message. Another one is DHCP decline. One more is DHCP release message and DHCP inform. We will understand this when we will be learning about what are the security measures you need to take to avoid any kind of attack related to DHCP. At that time, we will discuss these messages as well. But primarily, these four messages, discover, offer, request, and acknowledge, are the mainly four messages where the client gets the IP address assigned dynamically from the DHCP server. Now, going ahead with the discussion, what we are going to do is we will be performing a small lab. We will see how to configure the DHCP. Remember, Whether it is a router or a switch, the DHCP configuration is going to remain same. Moreover, in the router, you are configuring the DHCP from DHCP network or a DHCP pool from the interface IP address. And over here in this case, we are going to configure DHCP using, we are going to configure DHCP over a VLAN. That's only a difference, or else the configuration is same. And let's start the configuration now. So very first, I will log in over here on the switch. Remember, we have already done many configuration on this switch, like inter-VLAN routing, VLAN trunking protocol, and even in our previous lecture, we have configured DHCP for VLAN 20 for the VLAN 20 network in our previous lecture. But freshly, we will configure VLAN. We will freshly configure the DHCP over a 192.168.10.0 network, that is VLAN 10 network. So going ahead with the discussion, the very first thing what we are going to do is just to show IP interface brief, and you will see that already we have configured VLAN 10 with this network. Which network? 192.168.10.1. So if you just check the running configuration of your VLAN 10, it's a packet tracer and has a limitation, so this command is not going to work. Anyway, not an issue. I will show you the things over here. So what we have done, we have configured 192.168.10.1/24 on VLAN 10, and we are going to use the same tool for configuring the DHCP. Let's start with the configuration. So very first, you will go to configure terminal, and over here you will give the command ipdhcp pool, and you are going to define the pool name. I will say that the pool name over here is my DHCP pool. It is nothing but a name of your DHCP pool. The second thing what you are going to define over here is nothing but the network, which is 192.168.1.0 255.255.255.0 the subnet mask. Hit enter. The next thing what you are going to define over here is the gateway. The default router is a syntax, the command syntax default router, and the gateway is nothing but your VLAN 10 interface IP 192.168.1.1. Hit enter. If you want to add a DNS server over here, you can add that as well, so that automatically the DNS is assigned. And the command is DNS server, and the IP of the DNS server is 8.8.8.8. If you want to add multiple DNS, just simply put comma and you can do that as well. Over here it is not taking, usually it should take, but again it is something, the virtual lab environment, so it is not taking. It's totally fine. Okay, but if you want to add a DNS server, it is 8.8.8.8. Let me give a space and try over here. Again it is not taking. Anyway, so this is one of the DNS server 8.8.8.8, and hit enter over here. So over here you complete with the DHCP configuration. Now remember one more thing, the network which you have defined is 192.168.1.0/24. Now there is a possibility that you might be requiring some of the IP addresses for the static purpose. You want to define the static IP addresses. So it is always recommended that instead of using the complete pool, what you can do is you can keep some of the IP addresses for assigning it statically as per your requirement, and you can use the rest of the pool. For example, we have 192.168.10.0 network. So what you can do, like let's say first 50 IP addresses you can reserve it, and the remaining you can use it for your purpose for the dynamic assignment. So just exit from here, and the command which you will use to keep the IP addresses and not to be used for assigning it dynamically through a DHCP server, the command is IP DHCP excluded address. And over here you will say 192.168.1.1 192.168.1.50. So what will happen? Up to 192.168.1.50, the IP addresses will be reserved, and this will not be assigned from a DHCP server to a client, and the assignment will start from 192.168.1.51. Let's verify this practically. Hit enter. So let me show you what all configuration we have done now. So we have configured IP DHCP pool, this one. IP DHCP pool, the name we have given my DHCP pool, and network is 192.168.1.0, subnet mask 255.255.255.0. We have configured gateway, that is default router 192.168.1.1. Then we have defined the DNS server 8.8.8.8. Due to this virtual lab limitation, we were not able to configure multiple DNS, but in the real environment, you will be able to do that. And finally, we have said that whenever the DHCP assignment is done, don't use this range of IP address from 192.168.1.1 to 192.168.1.50. So what will happen? Now hereafter, the IP address, whenever it is assigned dynamically, the DHCP server will start assigning the first IP address as 192.168.1.51. Let's verify that. Now I will be going to this switch. Remember, this all configuration, this switch is this is a trunk link between the both the switches. Then this both pieces are in VLAN 10. This all the configuration we have already done in our inter VLAN routing lab. I will go to this PC. I will go to IP configuration and I will say DHCP. It is requesting for IP address, and we are not getting this IP address over here. Let's troubleshoot why we are not getting the IP address. What I will do is I will be going to the core switch over here on which we have done the configuration. So over here, if you will see, I have done one mistake over here. What is the mistake? See, if you check the network which is being running on VLAN 10 is 192.168.10.1, but the configuration which I have done for the DHCP, the configuration which I have done for DHCP is on 192.168.1.1. If you see, network is 192.168.1.0. It should be 10.0, right? So this is a mistake which I have done over here. It was a typing mistake. Instead of using 192.168.10.0 network, I use 192.168.1.0 network. And every mistake is a learning. So even you have learned something, like if you are not configuring the DHCP pool, the network, the IP addresses pool and everything as per the proper network, it will not work for you. So let's change that. What we will do, we will be going to configuration mode, and I will go to IP DHCP pool. Remember, you have to give the proper name over here, my DHCP pool. Okay, and you will just remove this, copy this over here and say no network. Hit enter. Similarly, remove this default router also from here. You can remove this also. Now what you have to do is you have to define properly the network, that is network 192.168.10.0, subnet mask 255.255.255.0. Enter. The default router is nothing but the VLAN 10 interface IP 192.168.10.1, and the DNS server is going to remain same, so we haven't touched that. And one last thing, this if you keep it also, it is not going to harm this configuration, but unnecessary why to keep, we will remove this. No IP DHCP excluded. Hit enter and configure the IP address from our network, which is 192.168.10.1 to 192.168.10.50. Hit enter. So every mistake is a learning, and if mistakes are happening, it is good. If I have done a mistake, it means that you have learned something. That's really good. And finally, now what configuration we have done? Show run pipe section DHCP. Hit enter. You will see that for this pool, IP DHCP pool, my DHCP pool, you have defined the network 192.168.10.0 with the subnet mask 255.255.255.0. Default router is 192.168.10.1, which is nothing but the VLAN 10 interface IP. DNS server is nothing but 8.8.8.8. And you said that whenever there is a IP assignment for this network, exclude this range 192.168.10.1 to 192.168.10.50, meaning the first IP address which will be assigned will be 192.168.10.51. Let's verify this. Just come over here on PC, go to IP configuration, and just refresh it. Go to DHCP. It is requesting for IP.